All right, folks, we transition into assignment number 28. This is called linear systems of equations with two variables. And first of all, it's called a system of equations because there's more than one equation, and we're going to solve them simultaneously. And the other word, linear, is because if you look at this, since there's two variables, there would be a graph of each, and they're both lines because you'll notice that the y and the x are all to the first power. And we've talked about that when your variable's to the first power throughout, there'll be a line when you graph it. Okay, so this again is example number 1. Now, I will tell you that there's a swatch of graph paper here on this example. I've learned that it helps explain the question if you graph it, but we're going to talk about how graphing helps us understand the question, but it turns out not to actually be the best way to solve it. So example 1 is the only one where we're going to graph it, so it helps us understand what's happening here. You will not be asked to graph these on assignment 28. This is just to help you understand the question a little bit better. So, of the methods that we will talk about to solve systems of equations, in your notes, you'll see that method number 1 is to actually graph it. And let's do that because it's fun and it's good practice. So, I've labeled these green and red. I don't know if you can see the colors very well, but the bottom one should be very easy to graph because it's already in slope-intercept form, y equals mx plus b. So let's graph that one first. Wouldn't it be easy to find an ordered pair? X is 0, y equals 6. All right, beginning point. So x is 0, y is 6. That would be a beginning point for that easy one there. And then the slope, you hopefully agree, would be -7 over 1. Rise over run, all right? And so from that beginning point, this is what? This is like assignment 19, I think, isn't it? All right, so anyway, from that beginning point, we come down 7 and over 1, and that gives us a second point, and then we get out our straight edge. Now the thing is, and we're going to talk about this later, there's a lot of possibility of being some human error when you graph things. And, you know, the accuracy visually isn't perfect. And that's the downfall, I guess, of graphing. So why are we even graphing it? It helps us understand the question, all right? The green one. Well, hopefully when you saw that one, you said to yourself, oh, we got to get that in slope-intercept form. You know, there's another way to graph it, but for our purposes, let's isolate y and make that top green equation look like the other one. So anyway, we would add the 4x over to the other side. We're getting y by itself. We're getting it in slope-intercept form. Oh, this is so assignment 19. All right, and so at this juncture, let's see, 3y equals 4x minus 15. And then you divide over the 3, get y by itself, get it in slope-intercept form. This is good review. Let's see, and then you can put both of those terms over 3, so that'd be 4/3 x minus 5. So it looks like that would be the rearrangement of that top equation. This is all old stuff. You're not going to be asked to solve these in this manner. This is just a visual to help us understand the question, all right? And it's good practice. Graphing lines. When x is 0, y is that number sticking on the end, -5. So that ordered pair would be 0, -5. Notice I made my scale accommodate the numbers involved, all right? And then the slope is 4/3. So from that beginning point, we'll rise 4 and run 3. Yeah, same thing. We've done this before, assignment 19. Rise 4, run 3. Rise 4, run 3. That gives us a second point, and we can draw that green one. Okay? So then we go graph that. I don't know if you hear my phone. I'm getting some texts. Once again, I think my agent is working on an endorsement contract for me. So depending upon the outcome of that endorsement contract, we may or may not have class anymore. Who knows? I'm hoping. All right? $7 million is what we're negotiating for, an endorsement contract with Texas Instruments. All right, here's the deal. We've talked about this before. When you have a two-variable equation, there's an infinite number of solutions. Every ordered pair, every point on that green line there would be a solution to that top equation. And every ordered pair, every point on this line would solve the bottom equation. So individually, those lines, those equations have an infinite number of solutions. But when you solve a system, the question is there anything that would solve both of them? And I hope you would agree that visually, that ordered pair, basically physically where they cross, that ordered pair would solve both of them, wouldn't it? So this is a picture that hopefully explains what we're looking for is, where do they cross? Because that ordered pair would solve both equations, and therefore that ordered pair would be considered the solution to that system. So I hope that picture helped you understand what we're looking for. Now the problem though is, what are the coordinates of that point? And this is the downfall with graphing. How do you actually find those numbers? So if you were sitting here, and I'll just have you guess from the comfort of your own home, looking at the board there, or looking at the one that you drew in front of you if you're playing along with me, I hope you are, what do you think would be the coordinates of that point? And this is where we usually play a game. So if you're going to find the x coordinate, wouldn't you scan your eyes up to the x-axis here? And it looks like it's somewhere between 1 and 2 maybe. I don't know, maybe it's 1, maybe it's 2, maybe it's a number in between. It's a guess. That's the problem with graphing, is what is that actual number? Okay? So typically when I ask a class, what do you think that is there? And again, it'd be great if I could ask you, so pretend you're here with me, I'll pretend I'm listening. What do you think would be the value of x right there for that point? Anybody? 1.5? Okay, yeah, it looks like it's between 1 and 2, maybe, I don't know. What if your line's a little bit crooked? What if your eyeballs are terrible? You know, this would be where you need to get out your detective costume and you'd have to go, oh, yes, oh, that looks like 1.5 on the x, doesn't it? I don't know why I'm talking like that. Okay. And if I was going to ask you to guess what the y value is over here, you'd scan your eyes over to the y-axis. I don't know, the way I drew it. What do you think? What's your guess? -3, you know? I don't know. My lines are crooked. There's human error involved in the graphing. So to graph things, you have to have perfectly straight lines. You have to have really good eyesight, okay? And I don't have either. So I guess my point would be this is all based on eyesight. That's a picture of an eye. And if you were going to stake your life on that, I hope you'd be like, oh no, I'm in trouble, you know? There's lots of questions there. Is that the actual point where they cross? I don't draw lines perfectly straight. I don't have good eyesight, I'm in trouble, okay? So, let's move on and talk about the fact that a technique called substitution will actually work better to find those exact numbers. It's called substitution because when you substitute things, you put one thing in place of another. And you'll get the hang of this. The reason this particular system is conducive to substitution is because y equals. And the idea would be this: if y is equal to that expression in this bottom equation, then we can put that expression in for y in the other equation. So just look for that. If one of your equations, or perhaps both, says variable equals, like this, y equals, then you can put that in for y in the other equation. And this doesn't require graphing perfectly straight lines and having good eyesight. Okay? So, if we make that substitution, put that in for y up there, and I've kind of painted myself in a corner a little bit, I'll adjust. Wouldn't that top equation be -4x plus 3 times expression? See, it equals y, so we can put it in for y. equals negative 15. See what happened there? This whole thing got put in for y because it's equal to y. So that's called substitution there. And I don't know, listen carefully here. No, okay, I'm sorry, never mind. So this now becomes a one variable equation, doesn't it? It only has x in it. And so we could flash back to linear equations, one variable. Oh, this is so assignment 8 at this point. Linear, x is to the first power, all that. So let's go through the steps. Let's see. Clear fractions? No. Distribute? Yes. Distribute the 3 into the parentheses. What else do you guys see? Oh yeah, have you guys been practicing your voice for this? Ready? 1, 2, 3. Combine like terms. Combine like terms. That would be negative 25x plus 18 equals negative 15. Oh look, that's a variable, that's a constant. They need to be on opposite sides, don't they? All right, so again, we need to subtract that 18 to the other side, because when it comes to variables and constants,
you gotta keep them separated.
and then after doing that, this equation is the offspring of the previous one. It's the offspring of it. Okay, I'm done with that. You can go check into that. And then, oh, I want x by itself. Let's get rid of that negative 25. The exact value of x in that ordered pair is 1.32. You guys guessed 1.5. You need to get your eyes checked. Ha ha, I'm being facetious. Obviously, there's no way, well, there is a way, I guess. But if you could have looked at that picture and known that that was 1.32 there, then you need to go join the math circus, okay? And I don't know if there is a math circus, but if there's not, there should be, right? That ordered pair actually has an x coordinate of 1.32. Now we're talking exact, all right? Goodbye guesswork, okay? It's 1.32. Okay. The picture also helps us understand, because any algebra teacher will tell you that a lot of times when a person gets a number, they're like, I'm done, right? I got a number. But you need to realize there's also the y coordinate that needs to be discovered. We're not done. How would you maybe find the value of y? Oh! Let's go put that 1.32 into one of these. I hope the picture also explains that to get the y value for that ordered pair, it wouldn't matter which equation we use. The red one, the green one, doesn't matter. Either one should give you the same number, shouldn't it? So it's just a matter of which one do you think makes more sense. And I hope you would agree with me on this one, that if you want to know what y equals, it would make sense to put that number in to the equation that tells you what y equals. So we will put 1.32 in for x in that bottom equation. We could have done the top one. It should give you the same number, right? It's the same number on both of them. And so then that 1.32 times negative 7, and then add the 6. I did both steps. And it turns out that y equals negative 3.24. And again, look, you guys guessed negative 3. It was negative 3.24. Get your eyes checked, man. All right, but anyway, there. Those are the exact coordinates of that ordered pair, and therefore that ordered pair solves both equations. I think that's everything I can think of that would be related to that. So again, just to wrap it up very quickly, and there's other techniques we'll talk about. But graphing, we're done with it. It helps us understand, we're looking for the point where they cross, but as this hopefully demonstrated, it would be very difficult to get those exact numbers graphing perfectly straight lines and using your eyeballs. So that's example one, and we'll just keep adding to this. Alrighty,